All right, so this is sort of a cryptic title, but this stands for geometry, semester 2. We're in the first unit. The first unit is trigonometry. This is the 6th lesson, which is called tangent, adj, leg, and inverse practice. It sounds like a secret code there. But that's what this lesson is on. It's on the tangent, the adjacent leg, and the inverse tangent. This is all from creatormath.com. Go to that tab, which is geometry, and find this lesson name to match the video and the assignment. This one says copy the following problems 1 through 15 into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So don't forget the notes. I cover a lot of things in these problems, but there's a lot of things in the notes that I don't cover. So the notes are an important base to being able to do these problems. All right, this should start to look familiar to you and even be repetitive, and that's part of the point. There's an old saying that if you repeat things, you can get good at it, right? Here we go. So given the figure below, what is the opposite leg or op leg for the given reference angle? So let's go back through the whole process here. This is a triangle. It's a right triangle because in this vertex or this angle or in this corner there is a square. The square means that this angle is exactly 90 degrees, and that is the definition of a right triangle or a 90-degree triangle, a triangle with exactly one 90-degree angle. The reason it can only have, a right triangle can only have one 90-degree angle is because there's two other angles here and here. And the sum of the angles, those three angles, is 180. If we take 180 minus this 90, we get 90. 90 has to be split between these two, so they must be less than 90. So, in addition to a right triangle and all triangles, there are three sides. They're labeled side A, B, and C. They have names. A triangle has two legs, and I always say like a human, trying to get my students to remember that. The legs are attached to the largest angle, right? The legs are attached to the largest angle. In this case, it's the 90-degree angle. So there's two legs. The third side is called the hypotenuse. We'll talk more about that in a second. The hypotenuse is the longest side, and it is across from the largest angle. This is asking us what is the op leg or opposite leg to the reference angle. So always in trig, we're looking at the remaining two angles of the three angles of a right triangle. So this one is 90. We don't have anything to do with that. We already know its measure. We're either considering this angle here or this one here. And however it is, the one that we're going to look at is going to be marked somehow. In this case, it's marked with a Greek letter alpha. That's what this symbol means. And that is a variable that stands for the measure of this angle. This angle is left blank, and therefore we are ignoring it in this problem. So alpha is the angle we're talking about, and now we're talking about the opposite leg. So we got two legs, one here, one here. The opposite means across from the reference angle. So start at the reference angle, come across to side A. This is the opposite leg from this reference angle, and we abbreviate it op leg. So this would be side A. Now they're going to ask us for the adj leg. So once again, we have a reference angle here. And that's what they're saying to us. They're saying, given the figure below, what is the adjacent leg or adj leg for the given reference angle, that being this reference angle here. And the interesting thing is that when the reference angle shifts over to this location in the problems that follow, we're going to see that the adj leg and the op leg change, right? They change based on where the reference angle is. So this is a leg and this is a leg. A triangle has two legs like a human. The legs are always attached to the largest angle. The third side is called the hypotenuse, and it's the longest side across from the largest angle. So in this case, adj means next to, adjacent means next to. So the leg adjacent to the reference angle is side B. That's the one touching adjacent next to. Now that we've talked about two sides, the legs, in relation to the given reference angle, which is here the alpha, we're now going to be asked, given the figure below, what is the hypotenuse? And I always try to get my students to spell it. Hypotenuse. It's a strange word because it comes from 2,000 years ago. But it breaks into three words for me. Hypo I can spell, ten, T-E-N I can spell, and use I can spell U-S-E. Together, though, we don't say hypotenuse. We pronounce it all together smoothly, hypotenuse. All right, everybody repeat after me, hypotenuse. Okay, so hypotenuse has two aspects to its definition. It's the longest side, and we can see here visually that side C is the longest side, and it is across from or opposite the largest angle. So this side C is the hypotenuse, and we abbreviate it hype all the way through, side C. Given the figure below, what is the reference angle? By now, if you've been watching these videos, you should know that we use alpha and other Greek letters to represent variables for unknown angles. This unknown angle right here is the reference angle. It's the one we're focusing on, and it's got an alpha in it, and that's all they're trying to get us to do. This angle we're ignoring because there's nothing there. There's nothing focusing us on this angle. And this is 90 degrees. We already know it. So always in these situations, we know one. We're only looking at two possible, and one will be designated for us, and it is called the reference angle. Given the figure below, what is the opposite leg or op leg for the given reference angle? Now they're going to illustrate to us that the reference angle can change location. So originally they told us alpha was over here in this angle. Now we're moving it to this angle over here. As the reference angle moves, so does the op leg. Since the op leg is the leg across from the reference angle, it is now side B. If you remember when alpha was here, opposite leg was over there, side A. So something that really catches students off guard is, wow, the op leg and the adj leg can change locations based upon the reference angle. The things that don't change location are the fact that these two are legs, and they are attached to the largest angle, and that this side is a hypotenuse. That does not change, and they're going to ask us that in the next question. All right, so side B is the op leg from this reference angle. Side B, op leg means across from. All right, given the figure below, what is the adjacent leg or adjacent leg to the reference angle? So now they're showing us if the reference angle's here. These are the two legs. A triangle has two legs like a human. They're attached to the largest angle. Adjacent means next to. This is the reference angle alpha in this case. It's side A. This is the leg adjacent or next to the reference angle alpha, side A. Given the figure below, what is the hypotenuse? Hypotenuse is the longest side and the side across from the largest angle, side C. Notice the alpha moved from one location to the other. The reference angle or the angle in question changed, but the hypotenuse did not change. The hypotenuse remains the longest side no matter where you put the reference angle. On the other hand, the adjacent leg and op leg do change based upon the movement of the reference angle. Given the figure below, what is the reference angle? Now they're just trying to focus on the fact that this is an alpha, and they're trying to get us to say the word alpha, right? That's it. In trigonometry, which they're identifying as sine, cosine, and tangent, we only work with 90-degree triangles. That is mostly true. However, we are going to do law of sines and law of cosines, and that catches students off guard because law of sines and law of cosine works with non-90-degree triangles. But in terms of sine, cosine, and tangent, we're primarily working with right triangles and 90-degree triangles, and that's what you see in these beginning assignments. Next thing for you to learn is Sohcahtoa. Everybody repeat after me, Sohcahtoa. Okay, good. So, Sohcahtoa. So helps us remember sine is the op leg over hypotenuse. Ka helps us remember that cosine is the adjacent leg over hypotenuse. And toa, tangent, is the op leg over adj leg. In this case, we're working with the tangent function, so we're going to be focusing on toa in this lesson, right? Which is tangent is the op leg over adj leg. Okay, then the definition of tangent function is, so now this is their form of alpha, right? It really looks like an A to me. But what you have is tan alpha equals, and here's the definition, O stands for op leg over adj leg, ADJ leg. Right? That's the definition of tangent. Here it is here. Now they're going to ask us to apply it. So this one is op leg over adj leg. Let's go to the next, number 12. And it says set up the trig function for tangent. So let's write tangent alpha equals, and this is the definition. I could memorize this, or I could just memorize Sohcahtoa and come out with, Toa and know that its tangent is op leg over adj leg, right? Okay, here we go, so I can get it all in. This is over adj leg. All right, in this case, look, they don't use an alpha, but they're clearly showing us what the reference angle is. There's a question mark degree. This is the reference angle. This is the angle in question. So when we talk about op leg and adj leg, it's in relation to the reference angle in this place, not over here. Notice this is blank, so we're going to ignore this angle. This angle we know is 90 degrees, so it's completely not interesting to us at all, except for the fact that it's 90 degrees. This one is question mark, so we have tan alpha equals op leg, so come across from the reference angle, opposite or across. 15 is on top of the fraction, do a fraction bar, just like in the definition of tangent. And that's over the adj leg. This is a leg, and it's adjacent to the reference angle, 12. So this is the setup, and if I have time, I'm going to come back and plug this into my calculator. But tan alpha equals 15 over 12. That's my answer for the moment. All right, for the following figure, what is the proper setup using the tangent function? So once again, we're going tangent alpha equals op leg over adj leg. We don't know this one, so it remains alpha. That's our variable. We're going to come op. In this case, it's a 15. We're going to put it over 7, which is the adjacent. Now, notice what they've done. They've tried to illustrate us something. If we want to find the answer to this alpha, and if I get time, we'll try the calculator, we're going to leave alpha here because we don't know it. The tangent can be moved over to the other side, and it's like a reverse tangent. We can now go backwards. So if we knew the angle, we would use tangent, but now we don't. So we're going to have tan to the minus 1, and this is going to go in the parentheses, 15 over 7. And that way we'll solve. That'll give us the angle of this measurement right here in degrees. For the following figure, what is the proper setup using the tangent trig function? Here we go again. Tangent alpha equals op leg over adj leg. And I hope in here you can see Toa, T-O-A, Toa, as part of Sohcahtoa, or Sohcahtoa. So tangent, in this case, we have the angle, so tangent 27 degrees. I'm going to put that in. Now, we don't know what the op leg is, so we're going to call this x. The op leg goes x. We do a fraction bar. The adj leg is right here, 5, so that goes in here. We can use equation solving techniques. We can multiply both sides by 5. The 5 cancels out because it's 1, and we're going to come up with what the x equals if we plug this into our calculator. For the following figure, what is the proper setup using the trig function? One more time. Tan alpha equals op leg over adj leg. Right? Here we have an angle measure, so that gets plugged in for the angle measure. Tan 27 equals op leg is 14, so that goes on top. We don't know what the adj leg is. It's an x. In this case, we're going to use cross-multiplying techniques. We're going to switch those two locations, and we're going to say that x equals 14 and move this entire tan 27 degrees underneath the fraction in the denominator position. All right. We're going to put x is approximately equal to, and you're going to get out your calculator, and this is mine right here. Almost all phones have the standard calculator. You're going to open this up. Let me clear this out. And then remember, for this calculator, we need to go ahead and flip it on its side. Notice that the expanded calculator opens. Put this like this, where I can maybe see everything at once. All right, couple things. Make sure you're in degree mode. See how I clicked radian and it went to degree, and now it says radian up here. I click it again. That means I'm in degree mode. I'm going to plug in 14 divided by tan 27, and I'm going to get x, which is the length of that missing side. So I'm going to say approximately equal because we're going to round off the decimals. Let's take 14 divided by tan 27. So notice I have a tangent right here. Tangent, it gives me the parentheses already. Put in 27, and I'm going to close it with a parentheses just so it looks more like this. Notice the divided by. I get 27.48. All right, what is that telling me right here? It's telling me that this side is 27.48 long. Right? That's how long that side is. All right, let's try plugging this one in the calculator. Here we go. This says I'm going to take 5 times tan 27, and I'm going to find out the length of this side here. So let's clear this out and say 5 times tangent of 27 degrees. Parentheses. And I'm going to get 2.55. X equals 2.55. Right? That's the length of this side over here. Okay, let me keep going. Let's see if we can find an angle. In this case, we're going to find the inverse tan. Let's clear this out. So we're going to say alpha equals inverse tan of 15 divided by 7. Notice that if you do the second key, all of my trig functions go to the inverse tan, which is to the -1. And this is totally different than x to the -1, which is 1 over x. This is just a reverse tangent function, or reverse cosine or reverse sine. It's like division is to multiplication or subtraction is to addition. It's the reverse operation. So we have tangent of 15 over 7, and I'm going to do inverse tangent of 15 divided by 7, and close it with the parentheses, although I don't need to, but it looks a little bit better to me. And I get 64.98. So alpha is the angle is approximately equal to 64.98. That's going to be in degrees. That means this angle right here is 64.98 degrees. All right, let's go back. I want to try one more into the calculator. All right, this one is 10 alpha equals 15 over 7. Oh, this is the one we already did. We reversed it for the other one. Nope, I'm done for the calculator. So I want you to try your phone calculator too and see if you can make it work. Remember, the calculator is one way this way, but once you rotate it and you need to have your rotate lock off, the calculator switches to the more advanced calculator that's got the trig functions inside of it. Okay, find more about this on creatormath.com and match it up with your Schoology assignment.